Okay, so I'm going to give an end-to-end demo of DARE-TREFX. I'm going to run everything on my laptop. So I'll just start in the Docker Compose, which is needed for the dev environment, which is basically a Postgres database, RabbitMQ server, a MinIO server to represent inside the TRE, and a MinIO server to represent outside the TRE. Just start the solutions. This takes a while, so I'll just pause the video. Okay, so we've got 7 websites running in sort of reverse order, for want of a better word. We have a special version of Hutch that we've taken the Hutch source code. We've obviously jointly worked with Hutch to do the interface between the submission layer, also the TRE agent, and Hutch. We altered Hutch so that actually it fake calls the workflow engine and returns result, because we haven't got a working version of WFEX running here or available to us at this moment. We'll come back to that. What we've got is that all of development is the UI and a corresponding API, and the UI exclusively uses its own API. So anything you can do on the UI, you can do on the API. So it allows us to, as a really good integration point. So we've got the egress, which we'll see a bit later, and its API. We've got the TRE UI and its API, and we've got the submission layer UI and its API. So let's start on the submission layer, and we will sign in using Keycloak to sign in. Username testing, password 123. This Keycloak is hosted internet facing by the dev team at Swansea University. It's just straight up and down normal Keycloak. What we're presented here is logged in as Justin, and amusingly, the seeding of the application creates some projects. Head, shoulders, knees and toes, regressing into our childhood a little bit. So what we can do is we can go into one of these projects, and in here we can see there are no submissions. There's one person called testing on it, and we have the ability to add a user. We're going to do that now, and we can see the projects on it. All, as I've said before, all the forms that underpin adding a person, adding a TRE, adding a project are all customizable, because they're all using a forms engine, and they're just a JSON payload that can be altered on deployment. However, let's go a walkthrough of submission, because we've covered a lot of this in the other videos. So we have a choice. We can use the API, which is the original design, or we can use submission layer. Let's just look at the API very quickly. API, some crude instructions. It's telling us that we need to get a JWT token, which we get from here, which is after you log in, you can get it. And then it's going, okay, well, you need to make a TES, GA4JH TES message, including where the crate is here, and then you can example of using curl to use your token and submit that against the API. Or if you wish, you can go through the Swagger interface, and the Swagger interface is what we just saw over on the other web page a minute ago. Swagger requires us to log in with our JWT token, and then we would go down to here and we would submit our, well, we try that. We would submit our TES message here, and then press execute, and it would put it against the submission layer. But that's not for everybody. It's not everybody's cup of tea. So another way of doing it is to go into the UI and go to submissions and use the wizard. And all the wizard's really going to do is basically behind the scenes formulate a TES message, call the API using your JWT token. So you can use an external URL, or you can, if you've got a crate, you can just simply go and upload that. So I've got one here. This is the official test crate that the project's attempting to run our way through. Let's submit that. This is where we'll see an error appear. Hopefully the last error of the whole solution. There it is. We just say continue for now. Obviously we'll sort that error out. And refresh. So we'll sort that out. But everything has worked behind the scenes. So there is a submission testing 99, and if I go into it, I've seen it started here. It's been running for a number of seconds. This is where the message that was received, and you can see the two agents are it's waiting to be transferred to the agents. Now, this will fail, but I'll make it fail a bit quicker and explain why it's going to fail. So many windows open. Let's see if I can find the one that I need. So where are we? There. Yeah. So on the API of the TRE agent, there is a workflow engine called Hangfire, and it's set for it's a cron expression. At the moment, it's saying every 10 minutes, try and go and get your jobs. So if I just kick that off and make it go a little bit faster, then we can see here, if I refresh this page, the job is still running because we're waiting for this agent to put it down, and this one has been rejected. And that's just because in the middle you said that this project could participate with this TRE. Doesn't make it true. TRE has the ability to make their own mind up about what they want. So if I was to log into the TRE, again the decloak, as you can see, it's pulled down the projects that somebody's decided should be here. So there's head here, so you review it. We can decide either accept or reject. Well, I haven't decided yet. So we'll approve it. It's locally known as the project 99. These are credentials later on for WFEX. So press save, and that's authorized the project. So the next time it comes through, it will be allowed. However, you also then have to approve individual users on that project. So let's approve these two users on two different projects, and that bit's done. So if I now go, the submission is what it is. It went before there was approval, so that will never complete now. But if I submit another one, just do 100. Let's go for the same endpoints. Let's use a file again. Let's select this file and go. You see there are now two submissions, the 99 one and the 100 one. And again, if you go to the 100 one, you'll see it's waiting. So again, let us speed up time and synchronize the agent pulling the job down. We should now see that the crate has been validated. It's been sent to Hutch, albeit a fake Hutch. I'm going to have to update this quite fast because the demo doesn't. So you can see the progress through Hutch. These are all the defined stages that have been agreed with Hutch about when it's working and when it's not. So it's gone through the workflow, it's done its thing. Obviously, it's going to take a bit longer than that in reality. And Hutch has produced outputs, and they've gone to the egress website to be approved or not. So if we go over to the egress website, now the egress website at this moment is it's not finished. The UI's got some usability issues on it, but it is functioning. So let's log in. And if we look at the ones, there's only one being submitted by the system. So this is Hutch calling the relevant APIs to register the files. There are 3 files in there. This is where UI is a bit daft. There's this file, this file, this file, and you can approve or reject each file, and you can download the file and see what's inside it. If that's what you want to do, that's how you check the file. It has been agreed on the project you cannot partially approve, so you approve them all or you don't. So we'll do this. So approve that, and if we go back to the workflow, we should see that the files are now approved. They're now being packaged up by Hutch into a final submission and sent up into the system. And this entire workflow that's finished. See, we're still waiting for DPUK, but that's not even running, so that's never going to succeed. And we can download the output of the RO crate. Now, for demo, we've just got a text file, but this would be an RO crate as an output from Hutch, because Hutch would package up those files inside the crate, as well as the inbound files, and as well as the submissions and so on and so forth. Throughout all of this, there's been two buckets here. There's a submission bucket, which is stored in MinIO on the submission layer. So single sign-on. So here was the inbound crate. So we used the wizard to upload it, but if we were using an external URL, it would have downloaded it into this crate. So here's a forever copy inside this bucket, and the user here has read-only onto this bucket. And then there's also the output, so that when it's finished, the output goes out, and this is submission 5. And if we go to submission 5, this is the TRE code sale, and this was the file. And this was obviously be an rocrate.zip as a file for the real system, but this is where they would pick the files up. So that represents an entire run all the way through, submitting it through the wizard, or you could do exactly the same happens with the API. Going into the system, being accepted by the agent, being checked that it's valid, being pushed down to the Hutch. Hutch would then do its thing. We then fake what it's doing its thing. We call the egress engine. We basically the user validates the files are okay and approves them. And if it approves them, it tells the API, updates the workflow, uploads them to that external bucket, and then makes them available. The internal bucket is used for the interaction between Hutch and the agent as an intermediate store for those files that are asked to be egressed. So the internal MinIO is a private thing, whereas the external one, we're allowing the users to log in. We have made MinIO link up to Keycloak, so again, that single sign-on, you log onto the portal, you log onto the API, or you log onto MinIO, it's all the same thing. So it doesn't look much. There's a lot of engineering behind it, and just like the top of an iceberg, this is just a place where all the penguins are having a lovely time. Underneath, there's quite a lot of moving parts, but here, this concludes my demo for today. Thank you.